All right, so let's talk about. I think this is all we've done today. All right, first is there are some base units of measurement that we need to know. Length, we use a metric system in science because that's what the rest of the world does, and we need to speak the same language. So length is done in meters, mass is done in grams, time is done in seconds, temperature we do Kelvin, which is an extension of Celsius, which we talked about. The amount of a substance is a mole, which we'll talk about more in the next unit, really. The abbreviations here, the M for meters, the G for grams, S for seconds, that's all important to know. Volume, we measure things in liters, which trivially is a decimeter cubed. We talked about how a milliliter was a centimeter cubed, and that's a good thing to know, but on occasion they'll ask what a liter is, and that's a decimeter cubed. Pressure is atmospheres, but we'll talk about that later, and energy is joules. So beyond that, the things you need to memorize, these things, you need to know the relationship of kilo, centi, milli, micro, nano to the base unit. And the base unit is these things we just went over: the seconds, the grams, the liters, the moles, the meters, and the joules. Now this one has a lot of negatives here, as you can see. Oops. There's a lot of negative numbers, and that causes issues with calculators. So I prefer keeping things positive like this, where you would say that 1x, so the x here is any of these base units: the seconds, the grams, the liters, the meters, the moles, the joules. So 10 to the third meters equals 1 kilometer, and 10 to the third moles equals 1 kilomole, and 10 to the third grams equals 1 kilogram. That hopefully makes sense to you, that you would need a lot of these to equal one of those. And then for the rest of these that you need to know, the abbreviation, the prefixes make the unit smaller, so you need a bunch of them to equal one thing. So centimeters, it's 100 centimeters to make a meter, 1,000 millimeters to make a meter, 1,000,000 micrometers to make a meter, and I guess that's 1,000,000,000 nanometers to make a meter. So notice these are jumps of 3, 3, 6, 9, and that's a jump of 3. And that's important to recognize because when we do numbering, remember, we kind of keep commas happening every 3 zeros. And so that's why these jumps of 3 are so significant. The only one that's not a jump of 3 is the centimeters, and centi is 100, right? Hopefully you know that centi equals 100 equals 100, century and all that. It's a good keyword to know. All right. So I prefer you if you're going to memorize one, do this. You could memorize something like this, or I can help you if you want. Just always see, the nice thing about this is these are always one, and you don't have to worry about that. But as long as things are equal, then you can use it as a conversion. So we talked about Dora, and Dora is always going somewhere and starting somewhere. So we got to start somewhere with the given, and we have to go somewhere, which is what is needed. And we'll cancel the units with conversions. And the best way to look at this is an example. But let's remember definitions. So like that 1,000 millimeters equals 1 meter. That's a definition. So that's not one significant digit. We consider those infinite significant figures. So any of those, 100 centimeters equals 1 meter. That's not considered one significant figure. We consider that infinite because it's a definition. All right, so if we were going to do something like 240 kilometers to meters, and let's see if I can't do that to meters. All right, you would look back on that list and see that it takes 1,000 meters to equal 1 kilometer. That was supposed to be red. 1 kilometer. Okay. So here is our toolbox, so to speak. So where are we starting from? The number tends to tell us what we're starting with. So we're starting with 240 kilometers, and we're going to meters. So we're headed toward meters. That's where we're going. And we need to get rid of the kilometers and preferably go right to meters. Now, meters is the base unit, so this is going to work very well for us to just use this definition we have. So the 1 kilometer, we're going to want to put into the bottom so that the kilometer, thanks, pen. There we go, blue, red. There we go. 1 kilometer. Now the kilometers will cancel, the units of kilometers will cancel, and we're going to go to meters, which is the base unit, and that happens also be where we're trying to get to. And so that's 1,000 meters. So 1,000 meters in 1 kilometer. This is called the conversion factor, which is up here. It's something that's equal that we use to cancel our way through. So kilometers will go away, meters will be left standing, and because they're left standing, that means that's the unit that we have right now if we do the math. And since that's the unit of what we're trying to get, then it's a good idea to just do the math and be done here. So 240 times 1,000 would be 2.4 times 10. Just so that's 10, right? If you put 2.4, that's times 10 squared, that's 10 to the third, so that's 10 to the fifth if you're doing that math. If you don't like that math, it's just 2, 4 with 4 zeros, 1, 2, 3, 4 meters. Either of those is acceptable. All right, so that is an example where we're going to the base. If we were going from the base, so let's say how many nanoseconds in 0.013 seconds. All right, so we're going to start with this number, the 0.013 seconds. And we know from the thing that we had before, 1 second is equal to, that would be 10 to the 9th nanoseconds. It's a billion nanoseconds in a second. So if we're going to start with seconds and we're trying to go to nanoseconds, we're starting with the base. So this is only going to be a 1-step process. We want nanoseconds on the top. So we want that 10 to the 9th on top. And we want that second, that 1 second in the bottom. And we want that there so it'll cancel with the seconds that we're given. So the units of seconds cancel. And now we just multiply 0.013 times 10 to the 9th. And that will give you 1.3 times 10 to the 7th nanoseconds. And if you want, you could have also just done 6 zeros, 1, 2, 3, 4, 5, 6, 1, 3 nanoseconds. Either one of those works. All right, so let's discard all that, and we'll do one more that shows. We'll do one more that goes from one prefix to another. So if we wanted to know how many kilograms are in, and we'll switch our color here to, that's an N, by the way, 0. Nope, wrong way. Let's go. Yeah. All right, listen to some music while I erase all this. All right, how many kilograms are in, this is the problem when you just make stuff up. Let's say 335,000 micrograms. So it's micrograms. All right, so we're starting with the number. So it's 35,000 micrograms. And we're going to kilograms. So we're going to kilograms. And we're going to need some equivalences, some conversion factors. So if we go back to our list, we're going to see, I guess I'll just keep that 1 kilogram is equal to 1,000 grams. All right, so that's 1,000 grams. And we're also going to see that 1 gram is equal to, if I can switch back here, 10 to the 6th micrograms. All right, so these are the two conversions we're going to need, because we're going to need one for the kilograms and one for the micrograms. And on our chart, those are the ones we know. So of these two, the first one we're going to use is the one that gets rid of micrograms. So we're looking at this one here to get rid of micrograms. So we're going to want to get rid of micrograms, we're going to want micrograms in the denominator. So 10 to the 6 micrograms will go in the denominator, and 1 gram will go in the numerator. So that gets rid of micrograms. Right now, the unit that is standing is grams, and we want kilograms. So that's not great, but we did get rid of micrograms. So that's a step in the right direction. So the next thing we're going to do is go from grams to kilograms. And so we're going to use this one here that says 1,000 grams is equal to 1 kilogram. All right, and that'll cancel the grams as units. The only unit standing now is kilograms. So we're going to multiply the tops. 35,000 times 1 times 1 is 35,000. And we're going to multiply the bottoms. 10 to the 6th times 10 to the 3rd is 10 to the 9th. Right? So that's 10 to the 3rd. That's 10 to the 6th. And then when you divide those, you're going to get 3.5 times 10 to the minus 5 kilograms. Which would be 0.4035 kilograms. All right. I think that's right, because that's 3.5 to the 4th minus 9 is minus 5. Yeah. All right. So hopefully that's helpful. Conversion factors are equalities that change the units, and that's basically what we were just doing. And the other thing now, hopefully you noticed, and we talked about how it's all about the base, that if you're starting at the base or you're ending at the base, this is a one-step process. So you either have something with a prefix like micro or nano or whatever, and if you're going to the base, so microseconds to seconds or milliseconds to seconds, it's going to be a one-step process. And if you're starting with the base like meters and you're going to kilometers or centimeters or whatever, that's a one-step process. It's a two-step process when you start with a prefix and you end with a different prefix. So if you start with kilometer and go to micrometers, if you start with centiliters and go to milliliters, or whatever it is you're going to do, it's going to be a two-step process, and you always have to go through the base. That's the most important thing to remember. All right, so how many centiseconds are in 45 seconds? That is going to start with a prefix. Centiseconds is a prefix, and it's going to seconds, which is the base. So that should be a one-step process. We got seconds equal 100 seconds. 1 second equals 100 centiseconds. We want to cancel those seconds like that. Centisecond stands. Kilograms to milligrams. Now we have 2 prefixes. So we're going to have to go from milligrams to that base, and from that base to kilograms. All right. Right then. That's what we're going to do. So the other thing we should